Here is the simplest possible offline available application. It's hosted on GitHub pages because here everything is served over HTTPS, and as you already know, HTTPS is a necessary condition for offline support. And here is how the application works. We have a single image here, and we can change its scale by clicking the mouse buttons. The project contains 4 static files. A very simple HTML, a JavaScript file that tells how to handle mouse clicks, a CSS file, and an image. We can provide offline experience by caching these files and serving them independently of internet connection. Here we have a service worker file that implements this caching behavior. This code isn't run automatically, you need to tell the browser that you want this service worker to control this page. Somewhere in your main JavaScript application you say, please register a service worker that lives in this file. Pay attention to the path. By default, a location of a service worker file determines what pages it will control and what requests it will intercept. This service worker file lives at the very top, and thus it will control everything under this origin. It will intercept requests to all resources hosted here or below in the file system. For instance, it will intercept all requests listed here. Plus, it will intercept all requests made by the controlled pages, I mean even cross-origin requests. A location of a service worker file is just a default scope, and you can easily set a different scope in your code. Okay, so when the browser gets to this register call, it doesn't simply run a code inside a service worker, but it launches a complicated lifecycle of a service worker. And we can handle all these lifecycle phases and do something useful at each phase. For now we are interested in just 2 events, install and fetch. Service worker is installed only once in his lifetime. And if we want to cache some static files of an application, we usually do it on installation, but not necessarily. Doing this on installation step guarantees that everything will happen in the right order. First we cache files, and only when it's done we may start intercepting requests. Here we tell the browser to create a new entry in the cache storage and put these files into this new entry. Unfortunately, we can't just magically cache all the static files, we have to specify them one by one. And it makes sense because you have to be cautious with what you cache. If any of these files fail to download, a service worker will fail to install, and offline support will be lost. And of course, we don't want to exceed the memory limits by caching too much, though actually these limits seem to be very wide. This caches property stands for the cache storage, and it's available not only in a service worker, but anywhere in your client JavaScript. By calling an open method on this caches object, we create a new entry of this name. In this case, this already happened, so we can see it in the application tab. A cache entry called offline site is populated with 4 static files. Next, we need a block of code that handles requests and uses the cached files to provide some response even without internet connection. We'll look for a requested resource in the cache, and if it's there, we return it. If there is no such cached resource, we make a request as normal. And finally, we respond with either cached response or real fresh response. And I bet with all this code my website works independently of connection. Let's try it. First, let's see what happened on my first visit to this website. I'll clear the cache storage, kill the service worker, and empty cache with hard reload, so it looks like I've never been here before. Firstly, we downloaded the static assets as normal, then a service worker file, and then static assets again, and this was initiated by a call to cache add all inside a service worker. All assets were put into cache storage directly from HTTP cache, so we didn't have to download anything twice. Now let's go offline. There is a checkbox for that inside the Service Worker tab, but you may as well use the good old drop-down in the Network tab. Let's navigate somewhere else and return to my website. So here we have a real network-independent website that works fast and without connection. That's cool. In this case, all files were provided by a service worker. But if I refresh once more, we'll see a different picture in the network. This time, for some reason, HTTP cache comes into play. Frankly, I can't explain why this happens differently every time, but it's a perfect time to think about the relationship of two caches, cache storage and HTTP cache. Basically, our static files were cached twice, and perhaps it looks a bit inefficient. HTTP cache could provide most of the static files, so actually we could avoid putting them into cache storage. The only file that can be cached and served exclusively by a service worker is the HTML file. So in your real projects you can be more pedantic and build some very clever system where two caches are used in a most efficient way. But in this example I stick to using cache storage for all files, just because it's simpler and I don't have to think about HTTP headers. And by the way, here is the cache control header that is set by default on GitHub pages. Everything is cached only for 10 minutes, so it's of course completely unreliable. Now what about a normal experience? I mean, how these offline tricks affected the performance of those clients who are online and maybe on a slow connection. Let's go back online and refresh. And everything was loaded instantaneously as well. Switch to slow internet. Same effect, no network delay. So this website is very fast on any connection. It's kind of amazing how much we can achieve with this small code, but in real life this won't be enough. There are several problems that this code doesn't solve. First of all, what will happen when our static files will change? Frankly, this service worker can cache files only once and forever, so the clients will never get any updates unless we install a new service worker that will re-download everything from scratch. And we definitely have to fix this problem later. And there are many other problems that have to be solved by a real service worker. It gets especially interesting when we have to update a service worker. In other words, when we write a new service worker that will replace an old one. In such cases, we'll have to do some extra work to ensure that this migration happens gracefully. Now let's refresh the key points. Later we will discuss how to manage our caches in a more realistic and healthy way.